Away. I think I'm gonna use away. So for this problem station number, the first one, state whether the following numbers are real or non-real. Something that I had to actually add. Okay, so if these numbers are real, we're going to say whether they are rational or not rational. Ne? So of course, what did I write here? Okay. Here, I'm saying I repeated the R's, but that was supposed to be real numbers. But okay, forget about that. All I'm saying is on these numbers we're gonna talk about whether these numbers they are real numbers or they are not real numbers, right? Of course, if they're not real numbers, they are undefined, and if they are real numbers, we'll talk about whether they're rational or irrational numbers, right? We start with this one, right? We have a negative, of course. I mean, forget the negative. Forget the negative. Look at square root of 3. We spoke about it. I made an example with it when we were talking about irrational numbers. So it was the first number that I made an example of, to say this is not, because it's not rational, because we cannot turn it into, we cannot write it in a form of a over b, right? Where of course a and b are both integers and b is not 0, right? So even if it's negative, it doesn't change anything. It's a real number, yes, but it's not rational, it is irrational. And then let's look at this one. Right, this one, the number here is 0. We have this thing, any number divided by 0. Hey, what am I saying? No. We have this rule that says 0 divided by any number, any number, right? 0 divided by any number is going to be 0. So here someone could have been tricked by this square root of 2 to say, square root of 2 is not a rational number, it is irrational. And since here we have a fraction of, where we have at least one, a numerator or denominator being irrational, the whole thing cannot be rational, right? It is irrational. So for this one, it is a real number, right? But I am arguing that what we have here, it is rational, because then the answer here is 0, which can also be written as 0 over 2. you see that. So 0, remember 0 is a what? 0 is a whole number. Yes, 0 is a whole number. So yeah, so this one, it is a real number, but it is not irrational. And then here we're having a negative inside our set, that it doesn't define, or it doesn't exist. When you put that in your calculator will say maths error, or basically the number is undefined. So this one, it is undefined. We have a beautiful thing here where we are dividing by 0. We already know that is not a real number. We cannot divide by 0. That is not a real number. And of course, right here we have something interesting, quite similar to what we have here. Like just a simple mistake, someone could end up saying we have this negative together, negative by negative is positive, and then the person ends up saying this, which is equals to 4, and therefore this is a real number and it is a rational number. It's a possible mistake, right? That is a possible mistake someone can make, but remember, it doesn't work that way, right? It doesn't work that way. Yes, it doesn't work that way. So this math error, or you will just say undefined, just like we did say for this example. Talk about this one, negative 1 over 3. Forget the negative, right? We did speak about 1 over 3. Of course, we even know that 1 over 3 is the same as 0.3 recurring, right? 0.3 recurring, and therefore it is a rational number, it is a real number. You look at this number here, this number, it exists, it's fine, it's not a non-real number, it is a real number. And in terms of it being a rational or irrational, it is irrational, because this low number, it doesn't, there's no pattern. You see, there's no pattern or repetition of numbers, right? There is not. And therefore we cannot write it in a form of, remember when I spoke about decimal points that we can write as rational numbers, there has to be either terminating fractions or there must be a repetition of numbers, whether it's a repetition of a single digit or a repetition of a couple of numbers, but there has to be a repetition of numbers. You see it, ne? And then for h, we talk about pi. Here we made this number interesting to say pi squared, and we try to add 3. Guys, don't be confused. Don't be confused. It's still going to be irrational because of this pi. The numbers, yes, it exists, but it's still going to be irrational. Another interesting one is square root of 9. Square root of 9, you know what it is, ne? It's 3. So you have 3 over 3, which is 1. So number is rational, number is a real number. Here you have a fraction where your numerator is a rational number. Yes, it is, but what I wanted to say is that your numerator is what is come on, bro, an integer, right? So we have a being an integer, but b is not. B is the square root of 2, which is I think is 1 point something, if not 0 point something. But yeah, so you know, for the sake, because of this denominator, you know the whole number is going to be irrational, because you cannot write it in a fraction form such that both numerators and denominators, they are integers. Yeah. If you want to simplify this, you can just multiply by square root of 2 over square root of 2, but the number that you're going to end up with is square root of 2 divided by 2. Yes, divided by 2. So you cannot, you see here now, the denominator is what? The denominator is a positive number and it's an integer, a positive integer, but then the numerator is now not. Remember, here it was the denominator. Do you understand? So it's not. Talk about this one. It is, for the fact that we have it as 22 over 7, where both 22 and 7, they are both integers, positive integers in this case, and b is not 0, it is a rational number. Yeah, but I don't know what number you will get if you try to write it as a decimal form, whether it repeats or not, but for the fact that we can write it as a fraction where both a and b are whole numbers, perfect. Real rational number. We look at this one. Of course, the number here, it repeats itself, and that means this decimal point, because of it being a pattern of repeated numbers, it can be converted into a rational number, so it's a real number. And I'm pretty sure by now we are able to tell the difference between a real, non-real, and as well as a rational and irrational numbers. So now we're gonna try to convert the following numbers into let me just draw a line here. Cool. So we're gonna do exactly that, try to convert these numbers into rational numbers, or fraction with a and b being both whole numbers. So natural numbers, or you could say like integers, but b cannot be 0. So let's focus on this one. You have, if I try to expand it, you have 0.63333. So what is happening? You realize, okay, the number that is being repeated here, it's 33333, and that number, look at where it is. So I forgot my dots. So we go step 1, you define it. Number 2, you multiply by 100. 100, it almost got me. The repetition comes here. So you have 100. That is 63.333, right? Wait. Yeah, I think here we're going to learn something very important. We're going to learn something that is very, very important. Remember the whole idea also of us, the whole idea of us multiplying by 10, by 100, by, is so that when we do step 3, it's so that when we do step 3, the decimal, the commas are going to minus each other. Like, so when we go to step 4 or at the end of step 3, we don't want to have any decimals. It's just gonna be whole numbers. So on that note, I think we learned something very important, because here if we go and say equation 2 minus equation 1, this is what we're gonna have. We're gonna have 100x. No. I forgot my x here. 100x right. We're gonna have minus x equals to 63. 0.6333. Right. You realize that once we do our subtractions, we're still going to have decimal numbers. Do you see it? We are still going to have decimal numbers. So now the question I want to ask you is, how do you think we are going to attempt this one? Are we actually supposed to multiply by 100 here, or are we supposed to at least perhaps maybe multiply by 10? Think about it. Yeah. So remember, I'm gonna repeat it. The whole idea why we multiply by 10 or by 100 whatsoever is that we want to make sure that when we do our subtraction, we do not have any decimal points there, right? So it's a big question. Now ask yourself, what can you do to make sure that you won't end up with those decimal points when you do your subtractions? So the only problem we are having is with the 6. Now this is me giving you a clue. The only problem we have is the 6 that we have there. Alright, so you realize now, if you multiply, say, equation 1 by 10, then you have 10x, and then here you have then 6.3333 repeating. You now realize that, look, you have the same numbers after the comma. You see that? Very, very important. Now you have the same numbers after the comma, which means by the time you go to step 3 and you do your subtraction, everything is gonna, the decimal points are going to disappear, right? So let's fix that. You have your 10, and then here you have 6.333 recurring. Alright, so we do our subtraction now. 100 minus 10, that is 9. 90. Yeah, the number I was putting there was scary. So we have 90, and then here, of course, now this 0.333 are going to minus each other. 0.333 minus 0.333, 0. And then 63 minus 6, that will be 57. Right. And just for the sake of space here, I'm gonna do step 4 here. So now you have 90x equals to 57, and therefore x will be 57 divided by 90. Right, you see what you have done now. I'm gonna go get a calculator, and we're going to look and confirm our answer with a calculator. Cool. So we say 57 divided by 90. Look, 0.6, then 3 starts repeating themselves. All right, that was marvelous. So with this example, we were able to understand the whole idea of multiplying. Why do we multiply by 10 by 100? Is so that we make sure that on the two equations, the numbers after the comma are the same, so that by the time we go to step 3 and do our subtraction, at the end of step 3 we don't have any decimal points. You understand? Cool. So here's the last one, the beautiful one. So step one, what we do, you will say let four point 939393, right? With that, and then number 2, you multiply by 10 this time. Wait, is it by 10 or by 100? Right, by 100. So then you have 100 x 493.939393 continues. So you realize the numbers that we have after the comma, they are the same from 1 and 2. That means when we get to step 3 and we do our subtraction, we won't have any problems. So we go again. That will be 100x So now when we do our math, we have 999x being equals to 489. Yeah, I think I got that one right. 493 minus 489. Cool stuff. So I don't have space again, so I'm going to do number 4 here, step number 4 here. So for step number 4, we are just simplifying. We are just simplifying to say therefore x is equals to 489 divided by, there's a 9 that I left here, 999. We go to our calculator, we like wait, yeah, 100 minus 1 is 99. 100 minus 1 is 99. So hey, 100 minus 1 is 99. So we have 99x equals to talala talala talala. We go number 4, we divide by 99 both sides, we end up with this number. So we put it in our calculator, divide by 99, we're getting exactly 4.93939393. So yeah, so that is just how we do this whole conversion thing, and I believe that is it. Yes, so I believe that's it, and I'll see you guys in the next video. We will be talking about completely different thing. See you there.